Many designers complain at this, like Nerbert Rocha, for example, who tried to overcome the gap between mathematical deductive and the artistic intuitive aspects by realizing architectures in which tectonics is the predominant component, inherently aspiring to some aesthetic worthiness of the structural language that is not always guaranteed. During the modern movement, the need to regain a unitary conception of architecture arose, and the project operation was finalized through the Constructive Act. And the structural conception entered stride in the design process as a fundamental linguistic background, both in the sincerely evident form structures of Alvar Aalto, Frank Lloyd Wright, and Ludwig Mies van der Rohe. We can also include some works of Zarine and Niemeyer. This is the symbol of our symposium, the Canaveras House in Pedro do Rio in Brazil. And also in the perfect integrated way of the works of Le Corbusier, Louis Kahn, and many others. In order to point out which are the relationships between mathematics and architecture in the contemporary era, we can distinguish these two approaches. Mathematics intended as geometry keep being distinguished from the mathematics intended as calculus. On one hand, we have the so-called operative geometry that uses standard traditional designing tools and produces essentially ideal abstract forms. On the other hand, we have analytic mathematics related to the numerical simulations, which uses computers and software and generally produces natural shapes. These are some examples of what I mean for the use of Euclidean geometry to produce ideal shapes and forms, including proportions, surface and volumes, etc. And these are other examples in showing that the use of analytic mathematics leads to the conception of natural shapes currently aided by computers and numerical algorithms, including the Rayleigh-Collet studies on reticular structures and structures based on cable equilibrium, of course tensile structures, and any kind of shape-resistant structure. Up to the recent development of the structural optimization procedure applied to the architecture, for example, to the avant-garde pair of architect and engineer Toyo Ito and Mutsuru Sasaki, and also Mutsuru Sasaki with Arade Suzaki. We can also include the tensile structures in this series. And the search for these natural shapes goes beyond the mentioned examples by exploiting all the possibilities of the so-called parametric algorithmic design, and also including genetic algorithms, and like explained in the presentation before, the suggestions of nonlinearity, complexity, the theory of chaos. And it's worth noting, in my opinion, that these new calculus-based models of nature, by using an expression of Grave-Lin, sometimes produces forms that are a bit far from nature. Anyway, today the generation of new forms and new shapes is mathematically based, and mathematics is essentially topology, and of course overall numerical simulations. I don't want to enter into details of language of topology, nor to discuss about the various sophisticated software available, but just to discuss the consequences of the use of these instruments in the architecture as a mere mathematical static exercise, becoming slaves of the deeply charming geometry that remains a completely different thing from architecture. These are some architects which exploit widely this approach, And then, to recall the two guidelines of above in the actual frame, I can recognize that in the architecture of the past was the technological development, although recently supported by the structural mechanic development, which promoted and influenced the constructed forms and invention of new forms. By contrast, at present, the possibility of creation of new forms is completely governed by the digital design and in some happy cases with the structural support of the optimal design. And the digital design today allows to imagine any kind of shape, and the structural models and related computational software allow to verify any kind of structure. And the technological possibilities supported by financial possibilities allow to build any kind of form. And this put in front to some drawbacks, some missed, but designer cannot be necessarily qualified and selected, and as happens in musical electronic compositions, the results can be casual, subjective, and sometimes noise, to use the word of the great composer Pierre Boulez. Moreover, the progress in the innovative design of the shape is not accompanied by a real progress on the building technologies, and in many cases the building technologies are very traditional technologies. Like in the case of the station roof of Santa Maria Novella in Florence, the project of Arate Sasaki and with Mutsuro Sasaki, the engineer, for which the engineers thought to a very complicated reticular structure, which has been also used in the realized building of the Qatar City Convention Center, in which this reticular structure must sustain the so-called flux continuous structure that you can see in the figures.